In this video, we're going to look at one of our transformations of the plane called a translation. A translation is a transformation of the plane in which every point moves the same distance in the same direction. So here we have the points A and B and C, and each of them is being translated. So notice each is moving the same distance and the same direction. Now this little A with the tick mark here is read A prime. And this is the notation that is used for all the different transformations. If we have an original point A, its image would be A prime. B translates to B prime. C translates to C prime. If we want to translate something more complicated, say a triangle, then we translate all of the points that define the figure. So if a triangle is defined by its three vertices. So if I had the triangle ABC, I would translate its vertices, and this would translate the triangle. The triangle ABC has moved over here to A prime, B prime, C prime. And notice that when you translate a shape, it slides without turning. This shape here has slid over to the right and a little bit up, keeping exactly the same shape and size, and it hasn't turned or rotated at all either. So it's a glide from one spot to another. That's a characteristic of a translation, that slide without turning. So in this class, we're going to use three ways to define a translation. First, we can define a translation by drawing a translation vector. Translation vector is just an arrow. The length of the arrow from beginning to end shows the distance of the translation, and the direction the arrow points, of course, gives the direction. So if I wanted to translate this trapezoid ABCD using this translation, I would translate these 4 points that define the trapezoid. So A would translate this distance and direction and move to A prime. And notice what we're doing in essence is we're taking a copy of this translation vector and sort of sticking it here so it carries you from A to A prime. Now this has been moved over here. It looks exactly the same. B is going to translate to B prime, C to C prime, and D to D prime. And then if I connect these dots in the same order, I will get the translated trapezoid. A prime, B prime, C prime, D prime. Kind of looks like 3D, like a gold bar or something like that. Notice that again, we have this slide without turning. A, B, C, D slid over to here. A prime, B prime, C prime, D prime. The second way we can describe a translation is we can do distance and direction again, but this time using words. Distance is done with appropriate units, like inches or centimeters or meters or whatever. And to describe direction, we're going to use a peculiar compass that's going to come again later second semester. In this compass, we designate to the right as the 0 degree direction, up as 90 degrees, and so on around the circle. So 0 degrees is going to be to the right. 90 degrees is going to be up. 180 degrees would be to the left. 270 degrees would be down. And if we came all the way back around, 368 degrees is again to the right. Now this seems a little bit overblown because why not just say to the right instead of 0 degree direction? The advantage of this is it lets us precisely describe directions that are not up, down, left, right. We can say in the 120 degree direction, and that means we know we're exactly going in this direction. We're not going straight up, which would be 90, but we're going 30 degrees past straight up, and we're translating in that direction. So for example, let's say we wanted to translate this circle, which has diameter 10 centimeters across from one side to the other, and we want to translate this circle 5 centimeters in the 210 degree direction. Now 5 centimeters is half the diameter. 5 centimeters is the radius. So we would get this. Here's our 5 centimeter translation. Notice the direction we're going is the 210 degree direction. We're going left and down, more left and down, 30 degrees past directly to the left. And also notice since we're translating by the radius of the circle, the point that was at the center has now translated and is right on the circle. In other words, the center of the translated circle is on the original circle. Finally, the last way we define a translation, and this is much more useful in coordinate systems, is we describe how much points move left or right and how much points move up or down. This is useful in a coordinate system. These are usually pretty straightforward. For example, let's translate this triangle 3 units left and 4 units down. So here we are, we're moving 3 units to the left, 4 units down. This point moves 3 units to the left, 4 units down, and this point moves 3 units to the left, 4 units down. Notice that we can compute how the points move using coordinates. 3 units to the left means decrease x by 3. Remember, the x coordinate goes side to side. So 3 to the left means x is decreasing by 3. You may recall that means we can write delta x for how x is changing. So the change in x is negative 3. And 4 units down means the change in y is negative 4. So the top vertex of the triangle, for example, which have coordinates 2, 5, right there, it's got coordinates 2, 5, translates to 2 minus 3, because we're changing the x-coordinate by 3. We're subtracting 3 from the x-coordinate. And to 5 minus 4, because we're taking this y-coordinate 5 and subtracting 4. And so the point 2, 5 translates to the point negative 1, 1. And we can see that happening in the picture. Here's the point with coordinates 2, 5. It translates here, and the image point has coordinates negative 1 plus 1. And we could do likewise with each of these other coordinates.